All right, let's see about doing part B of this example. Where does the graph have horizontal and vertical tangents? Okay, the only place it can have a horizontal tangent is where the dy d theta is 0. And the only place where it can have a vertical tangent is where dx d theta equals 0. So I'm going to copy these. I'm going to come down here and set them equal to 0. And then we'll figure out whether we have vertical or horizontal tangents at these places. So vertical, we'll have to set these equal to 0, and horizontal, these. And I'm going to go ahead and say, this is a difficult problem. This is more difficult than probably what you'll see in the homework, and certainly more difficult than I would throw at you on a test. But it's a good problem to look at. So vertical, let's do those first. So what we want to do is take this and set it equal to 0. And any solutions to this are places where we might possibly have a vertical tangent, not necessarily have to have one at all of them. So how do we solve this? Let's see, I'm going to factor out a negative sign. That's going to leave me with 1 plus 2 cosine theta. So now I've got to set these two guys equal to 0. Minus sine theta is 0, and 1 plus 2 cosine theta is 0. And I'm only trying to find the solutions between 0 and 2 pi. So sine theta is easy. It's equal to 0 here, here, and here. So that's at x equals 0, pi, and 2 pi. This one over here, if you solve this out for cosine theta is going to be, let's see, you get negative 1 and then divide by 2. So cosine theta is negative half. Now, there are a couple of ways you could solve this. One way would be to realize if cosine's negative, you've got to be in this quadrant or this quadrant. And for cosine to be 1/2, or negative 1/2, the reference angle has to be pi over 3. So both of those are pi over 3, which makes this one 4. This one's 2 pi over 3. This one's 4 pi over 3. So these are our candidates. Now, if you have forgotten how to do this, then the best thing for you to do is go back and learn how to do it again. The second best thing for you to do is to realize how to solve this using a computer. Here's what I would do. I'm going to turn that off for a second. If you've forgotten how to do this, just type in y equals cosine x, and then y equals negative 0.5, and then come over here and figure out where the two things intersect. Let's see. I'm going to change this to grid. So y equals cosine and y equals minus 1/2. That happens down here at 2 pi over 3. It happens again over here at 4 pi over 3. So if you need to use that method, use it. All right, so do we have vertical tangents at these places? Well, that's a good question. Here's the graph over here on Desmos, and I am going to make a hand copy of that over here. Let's see, it's got like this and this, and looks roughly like that. Let me try this one more time. All right, so the vertical tangents happen here, here, and here. I guess those two actually have the same tangent line, but it's two different values of theta where you get a tangent. This one, let's see, let me label this. This is 0, this is pi over 2, pi, and 3 pi over 2. So this one happens at 0. Let's see. So that's 0. Let's see, that angle right there is 2 pi over 3. This angle coming down here into the third quadrant is 4 pi over 3. And 2 pi is really the same as 0. It's just coming around again. So we get the vertical tangents at those 3 places. We don't get one at pi. And the reason is, over here at pi, like sticking out here, that's where the graph comes in and makes this like kink. So it doesn't happen there. But we do get 3 or 4, depending on how you count these two guys, places where you get a vertical tangent. All right, now let's attack the horizontal ones. And notice horizontal, you can already kind of look at it and tell there's going to be one there and one there. But let's figure out exactly where those occur. This actually is a tougher equation to solve, because we got to set this equal to 0. And so let's see, this is cosine theta plus cosine squared theta minus sine squared theta equals 0. And at first I looked at this and I couldn't figure out what to do. It's tempting right here. It's tempting to try to make this into 1, but you can't do that because this would have to be a plus here in the middle to make this 1. But there is an identity that'll work here. This guy right here, this isn't on the formula sheet, but it is in the front of the book. This is equal to cosine 2 theta. And that is also equal to, cosine 2 theta is equal to 2 cosine squared theta minus 1. So I can rewrite this equation as cosine theta plus 2 cosine squared theta minus 1 equals 0. You say, big deal, what good does that do? Well, we can actually factor this thing like it's a quadratic. So it'll have to factor like that if it factors. And we've got to figure out pluses and minuses. Well, both of these, one of them has to be a plus and one has to be a minus. I'm just going to fill it in and see if it works. All right, if I do that, this gives me minus 2 cosine theta plus cosine theta. So that would give me a negative here. So I did them wrong. This needs to be a minus and that needs to be a plus. That way, let's see, this is 2 cosine theta minus cosine theta leaves you with that. And the other two things check out as well. So this gives me 2 cosine theta minus 1 is 0. This gives me cosine theta plus 1 is 0. So cosine theta is negative 1, or cosine theta is 1/2. So where's cosine equal to negative 1? Right here at pi. So that's one candidate for having a horizontal asymptote. The others will be the solutions to this. And if you go through, that's going to happen at, I believe, pi over 3 and at 5 pi over 3. Yeah. Although I totally drew that in the wrong place. The numbers are right, but it's up there. All right. So these are our candidates for having a horizontal tangent. If you look back at the graph, it looked like this. Pi over 3 is up here, and 5 pi over 3 is down here. And my drawing isn't great, but if you look at the one on Desmos, that is where you have a horizontal tangent. So you get horizontal tangents there, but not there at pi. And the reason is that pi, it showed up on both of them. The derivative is undefined there.